I've had problem with them not recording if I go too long, so that's why I'm starting over here. So I'm still doing Chapter 6, Form C of the test, and here's my vertical tank, height of 15 feet, top dimensions of the tank are 8 feet by 6 feet, filled with water within 2 feet of the top. Determine the pressure at the bottom of the tank. Pressure just depends on the depth. And since this is all in feet, I'm going to use the 62.4 pounds per feet cubed times the depth. Well, if the water starts here at the bottom, it's only in 13 feet of water, so times 13 feet gives me a pressure of 811 pounds per, this is in feet, cancels one of the feet and becomes pound per foot cube, pressure squared. Pressure is the force on an area. That's how pressure is measured. Pounds per square inch or pounds per cubic foot or square foot. Sorry, did it again. That's the pressure. The pressure at the bottom is the greatest. As you move up, the pressure gets less and less until it's near zero at the surface. So if we want to find out how hard the water is pushing on this front side, it's pushing really hard on the bottom there. That many pounds per square foot. If I took out 1 square foot, it'd be like 800 pounds of like 4 times my weight pushing on that place, a square foot. And there's lots of square feet across there. And if I get up near the top, it's going to be close to 0 because it would be 0 times this. We need to add up how hard it's pushing on an area near the bottom, and then a little bit higher, and a little bit higher, and higher, and higher, and higher. So we got to make a strip of area. We're not looking at the volume. We don't care what the depth is, just the area. So the pressure is going to be 62.4 times how deep it is. So for this problem, most of you put the coordinate system bottom, but I'm going to put it at the top of the water to make it easy, and I'll put y positive there and x. So the pressure at this slice right here, this really thin slice, is going to be down y deep in the water if my coordinate system's at the top of the water. So it's going to be 62.4 y. That's how much pressure there is, pounds per square foot, times however many square feet is at that depth. Well, if I'm doing y this way, this is dy, the height of this rectangle, not the box, just the rectangle, times the width, which doesn't change, it's 6. So it's 6 times a thin height of dy. That's the area that the pressure is being applied to at that depth. This pressure at that depth times on that area, and we want to do it for all the areas between y starting at 0, pressure at the very top, all the way to the pressure at the bottom. And that's 13 feet down. And so if you set it up this way, all you have is 6 times 62.4 antiderivative of 0 to 13 of y dy, and y goes to 1/2 y squared. We plug in 13 times this, plug in 0, you get nothing, and it turns out to be, let's make sure I get the same answer as I got on my other one. It'd be 6 times 62.4 times 13 squared divided by 2, and I get the answer that I got doing it the other way in class, which is 31636. This is going to be pounds per square foot, or cubic foot, times feet, times feet, times feet. It's going to be pounds of pressure, of force. Of force. That's how hard the water's going to push on that. It's going to be like it's holding 31,000 pounds. That's 15 tons pushing on that side of the tank. Okay? Last two. Supposed to decide whether it's convergent or divergent. Now, some of you looked at this and said, oh, the power is greater than 1. That makes it go 1 over x is a divider. If it gets bigger in the denominator, the whole thing gets smaller, and you said it's convergent. But that's if it's going to infinity. We're not going to infinity on here. We're going to 0, and that causes division by 0. So our problem is we got to deal with what happens when b goes to 0 of the integral b to 5. 0 is the problem, so we have to set it up with a b here, or an a and a, of 3 over x to the 3 halves dx, to do this improper integral. Now, I'm not taking the limit yet, so I got to keep writing it. And I'm not going to integrate yet. I'm going to write this as integral from b to 5 of 3x to the minus 3 halves dx, which is the limit as b approaches 0. The antiderivative of 3x to the minus 3 halves, we have to add 1 to the power and divide by what we get. And so we get 3x to the 1 added to negative 1.5 is a half, negative 1/2 over negative 1/2. The new power is what we divide by. And we got to evaluate that from b to 5. Well, I'm not ready to plug those in. I want to simplify this a little bit. So it's the limit as b approaches 0 of negative 1/2 in the denominator. I would invert and multiply, so it becomes negative 2 times 3, or negative 6. And x to the negative 1/2 means it belongs in the denominator as x to the 1/2, which is the square root of x. And that we need to evaluate from 0, a b to 5. So now I'm going to plug this in this evaluation, leaving the limit on there still. And I'm going to put in 5 first, so I get minus 6 over the square root of 5. Minus a minus, so that's plus 6 over the square root of b. And now I got to try to figure out what happens when b goes to 0, gets really small. Well, the square root of 0 is going to be, or close to 0, is really small also. So this fraction, 6 divided by really small, that fraction will get really large. And so no matter what this number is, this is getting really large, and so this is going to grow without bound, and so it's going to diverge. And so that's all the further we can go. There isn't an answer for how much area under that curve. There's no value for this undefined or indefinite integral. And finally, we got another one. This time we're going to infinity, and that's probably the problem. And so we're going to write the limit as b goes to infinity of the integral 2 to b of 2 over x ln x to the third. To do this, we're going to make a u substitution. I'm going to let u equal ln x. du is going to be 1 over x dx. Multiply both sides by x, and I get x times du equals dx. So this becomes, I haven't taken the limit yet. I haven't tried to investigate what happens when b gets large. This becomes the antiderivative, and now I'm changing variables. So if x was 2, u would be ln 2. I could just put a question mark and change back to x's before I evaluate, but I'm going to do this. And if I put b, u would be ln b of 2 over x, ln is u to the third, and the dx is x du. And this is nice because the x cancels. And so I'm integrating 2u to the minus 3, which its antiderivative, we'd add 1 to the minus 3 and get u to the minus 2. We'd have to divide by the minus 2. We have a 2 that's already there. And so this becomes the limit as b approaches infinity of 2u to the minus 2 over negative 2, evaluated from ln2 to lnb. But now I'm going to go back to x's. I could just plug in lnb and ln2 into this, but I'm going to go back to x's. Limit as b approaches infinity. If I go back to x's, u is ln x, and it's to a negative 2 power, so it would go in the bottom as ln x to the positive 2 power. And these 2's cancel, but there would be a negative, and so it would be 1 over that. Evaluated now between, back to the original ones, 2 to b. And so now I can do the fundamental theorem of calculus, put in the b and put in the 2 and find the difference. So it's going to be the limit, I'm not taking the limit yet, of 1 over ln b squared with a minus a minus, which makes it plus 1 over ln of 2 squared, which is the same thing I would have gotten if I put in the lnb into this. I would have got that, and put ln2 in for the u, and I would have got that. Now I need to do my limit. What happens as b gets really large? Well, ln b grows also. It gets large. And if I take it to the square, it gets even larger, so I get minus 1 over really large. And when the bottom of a fraction gets really large, the whole fraction goes to a value of 0. This has no variable in it. B is not dependent on this, so this whole thing turns out to be, since that's 0, 0 plus this is simply 1 over ln of 2 squared. And that's what this converges on. So this one converges. It has a limited area under this curve. And if you wanted to do it in decimal, or if you chose to type that into your calculator, it's, I don't even have it here. Let's type it in. On 1 divided by ln 2, close parenthesis, put a parenthesis on the whole thing. Oop. And square the whole thing. And it's 2.0813 or 4, something like that, approximately. I would like the exact answer. That's a nicer one. Okay? And that's the rest of the test.